All right, hello, welcome to the Off by One security stream. I have a very special guest. We've got Jordan Wiens, who is one of the founders over there at the developers of Binary Ninja, and Vector 35 is the company, right?
Yep, that's it.
Okay, I always want to make sure it's correct. So, but he was kind enough to come on, and he's seen some of the videos I've done on obviously reverse engineering and disassembling, decompiling all the things, and we thought it was a great opportunity to have him come on and kind of show us some of the great features of Binary Ninja and just some of the quality there. And look, like, it's clear when you use the tool that little things that stick out when you're using tools like Ghidra and others, which I'm not picking on, it's free, but we learn a lot of lessons about fonts and about hotkeys and about things just making sense. And it's clear that there's a lot of thought put into the development of the tool to not have to deal with those things. One of the craziest things, and I'm not picking on Hexrays at all, I love IDA Pro, but one of the things that I thought was hysterical one time, I was at Black Hat training. This must have been over 10 years ago, definitely over 10 years ago. And Chris Eagle was the instructor. And if you don't know Chris, he's a brilliant reverse engineering guru.
And wrote the book.
Yeah, he literally wrote the book. And he, I think he's still at the Naval Postgrad School in Monterey, California. But he did a training on IDA Pro, Advanced IDA Pro. And I kind of wanted to go and sit that training just to see if there's anything like I could pick up as tips. The one major takeaway I took from that is when you accidentally undock one of the panes or windows, there's like no obvious way to redock it. Like, you're stuck. It's just floating out there. And he showed me, like, if you take the mouse and you drag it right on this little tiny gray bar that's between like the outer window pane and then the content itself, it expands. You have to leave it there for a second. It expands, and you can click on that, and then you can redock it. Like,
hidden
stuff like
functionality.
That.
Yeah.
So I'm really looking forward to learning some things that I don't know about Binary Ninja from Jordan. Please do. Steven got tests. Oh, yeah, I've always had tests. I got Starry Night over here. It's my favorite one. Like,
Nice.
But yeah, I usually wear a hoodie, right? But it's funny. I read the comments. I do some interviews with David Bombal, who is amazing, and I love doing sessions with him. But people love to comment on your clothing, your hair. Like, I think I said one of the recent videos, I wear a hat too much. So obviously that's stuck to me. So I didn't wear a hat. And one guy's like, he's too old to be trying to look emo. It's like, I'm not emo. I've been a musician my entire life. And I don't, let's just stop picking on me, man. But anyway, so I do encourage you to please ask questions. It's a great opportunity to ask Jordan, who is obviously an expert at reversing and Binary Ninja, of course. And he is being generous enough to give away a free license to Binary Ninja. And I believe, how are you going to give that away, Jordan?
You okay if we announce that like midway through the stream so people have to listen for a little bit before they?
Oh no, I don't mean give. I don't mean give
the trivia. We're gonna have a trivia question. Yeah, exactly. Yes. Yeah.
Trivia question. So you obviously have to be here live to win. There will be a trivia question. The first person whose comment appears, remember, there's a 15-second delay before your comment's going to show. The first correct answer when we get there will be the winner. Correct answer. So, all right. The internet is rough. Yes, it is rough. People are just wonderful. Anyhow, so I guess let me ask you a couple questions to start. While folks are thinking of some. Yes, the answer is Binary Ninja. You won. Wow. But what got you started in this? Like, what made you want to write a reverse engineering tool?
Yeah, so I guess I started like my career 20 something years ago, a little while ago. I'm a little older than I look. And doing like network defense. And then I started playing capture the flags, and I was like, oh, this hacking, like offensive stuff is pretty fun. If only there was a career I could do that. And then so after about like 7 years of network defense, I switched over to reverse engineering vulnerability research, like writing exploits. Worked for a government contractor, and that was super fun. Like, I loved the work, but I also at some point was ready to go outside and see sunlight, have windows on my desk, and I liked kind of being a little more public. So about 8 or 9 years ago, we started Vector 35 to build Binary Ninja. And so Binary Ninja started as actually as a capture the flag tool. So I was using, IDA Hexrays, even actually had access to Ghidra way back in the day, although we didn't use it very often. We were like playing these CTF events, which were very my day job was like long-term reverse engineering vulnerability research. And then CTFs where it's like quick. You have to like constantly be doing stuff. And like the one little feature we wanted was quick patching, was something that like IDA was just not good at. Still to this day isn't really one of its strengths, and just happened to be something we need to do a lot of with capture the flag. And so there was an early like Python prototype we wrote of it, and it was just kind of like a CTF tool. And then after a while, myself and a couple other friends that were working together were like, we could do this for real. Like, I think we could go and actually give them some competition and kind of, shake up the market. There wasn't really any other options at the time. I think Hopper had like just maybe come out, but there was definitely like not much else out there. Ghidra certainly wasn't out publicly. So we're like, yeah, let's go do that. And so we decided to start Vector 35, do commercial stuff and build the tools that we would have wanted to use back when we were doing that sort of stuff.
Yeah, that's awesome. Makes total sense. Wow. So let's think here. So I've got a bunch of questions, but I don't want to take up too much time with them. But again, audience, please do ask questions if you have them about the tool or just in general with Jordan. Happy to answer those with you. So what are tell me about some of the features that when you look at Ghidra, Hopper, IDA, whatever else out there that besides one you just said, like for example, Ghidra has collaboration. IDA doesn't have that. And
they do now. They do have their Teams thing as a separate service. Yeah.
Right. The cloud. Yeah. So what are some of the things?
Yeah. So we do actually have that as well. Like that's actually one of the things that so I'm actually we have an enterprise version. And so it is, that's why I've got this also, if you're familiar with Binary Ninja, this might look a little different because this is the 4.0 dev release, which is just so if people aren't aware, we have like stable releases every quarter, give or take. So 3 or 4 times a year, we release a new stable build, but we have development releases like constantly. Like we had like 6 literally yesterday. It was a busy day. As every, one of my coworkers is like pushing fixes and features. We do use LLVM sort of, not for decompilation, not for disassembly, not for analysis, but we use it for assembling. So like if I actually like make a new file and assemble something, that's actually going to go through LLVM's MC. Actually, it depends on the architecture. So some architectures it does and some it doesn't. But if I pick MIPS or ARM, I don't actually know any ARM assembly off the top of my head. NOP, right? It's not one in our V7, but it is in 64, I think. Yeah. So that goes through LLVM's MC if you just want to use like a quick and dirty assembler. And we have some examples. There's also like a plugin that can kind of like translate RIL into LLVMIR. If you're to that, that's a kind of longer story. So not really. Like we've never used Capstone like for disassembly. We've done our own ground up architectures, and we've actually released all of them except for one as open source plugins. So that's like a good philosophical difference. There's a really funny Joe Fitz did a really funny meme a while ago where you had like a quadrant of like the disassembler landscape, and it was basically like IDA, Ghidra, Binja, and Radare, I think was the 4th one, and it was like authoritarian versus and commercial were like these 2 axes, and so like Hexrays was authoritarian and commercial, Binja was commercial but not authoritarian, and then Ghidra was non-commercial but authoritarian, because it was NSA. It was just kind of a funny joke, but there's actually some truth to it. Like all of our all of our architectures are actually open source. If you can actually go and see how we do all of our architectures for the official built-in ones, and somebody even asked just about RISC-V. It's already there. We actually already have it. It's already in the version I'm running right here. Anybody who's got a license can check it out. It's not in the stable build, so in about 2 weeks, that one will come out. Nice. But that one, like, it's actually, because it's written in Rust, it actually lives here in our main like public open source repo. So yeah, here's the RISC-V plugin. And in fact, like Radare actually uses our ARMv8 architecture module as one of their backends. Like they actually use it, which nice. Pancake was like, "Are you sure? Like we can use this? You've got it." Like I was like, "Dude, we MIT licensed it for a reason. We're okay with it. That's fine."
Someone's asking about the sidekick.
Yeah. Sidekick is our like new AI thing too, which we will show off some more later.
Yeah, I heard that might be coming on the stream here in a little bit. Yeah. Nice. Yeah, so questions are popping in here for sure. I'll put this one up there. It's a bit long, so I'll give you a second to read it there.
Yeah, so that's a good question. We don't actually have a lot of. There's a plugin rather called Ripper. So in the plugin manager, there's one called Ripper, which specifically is about taking a piece of code and running it with Unicorn, like for emulating out some stuff. But there's no like first party built-in feature for doing emulation. It's something we've like thought about kind of for a while, but we really focused a lot on just pure static analysis initially. But I think it's probably going to be something that we'll tackle at some point, but not yet. But there are several plugins that integrate with it.
Cool. Is there anything big coming down the line, like in the next version or two?
I mean, so right now, like this 4.0 that we're kind of demoing here is got a ton of stuff. I actually did a live stream a few weeks ago where I showed off most of the features.
Cool.
But it's like, so RISC-V support is one that was just added. Project support. So the idea you can have like related, actually, that's what I've got like right here. Like if this particular project, right? Like I can have multiple files in like the same kind of analysis session. I can like connect them up. So if you have like a DLL and an executable and you want to be able to say, oh, all of these imports come from this library, you can actually have them both as separate tabs and like switch between them, follow cross references, like go back and forth between them. So that's a new thing we just added. That would say back to your other question about like, Ghidra. I would say a lot of, there were things that definitely Ghidra had that neither Binja nor IDA had out of the gate. Like the really nice synchronized split view was something that they had a while ago that both IDA and Binja have copied on. The collaboration is something we've both done. Although I think ours is like really, we had been working on our collaboration for a while. So we even have stuff like chat. You can track where users are. It's a much cleaner, kind of more usable process than either Teams or Ghidra's the way that they do collaboration. And then so Binja's biggest, like, I'll get this out of the way. Like there are things that other tools are better for. Hexarray still has top quality decompilation. Like there are absolutely still things where like you just pull up random binaries. I would say more times than not, they're going to have the better decompilation quality. That's like used to be almost always true. Now it's like less and less true. We're like closing that gap. And so I'm looking forward to, I feel like, getting there where that's no longer the case. I think compared to Ghidra though, we do tend to have higher quality output. We've worked really hard the last couple of years. Even if you used Binja 2 years ago, you'd be like, nah, there's no way. Like, no, it's totally true because like we've improved really, really quickly. Just in terms of like features, like Ghidra didn't even have for loop support until relatively recently, and we've had that for a while.
One thing, like, so there was this tool a while ago. It was from Zynamics before they got acquired by Google. It was called BinNavi for binary navigation, and then I don't know how to pronounce his name properly, so forgive me. He's going to be on a stream soon, though. Jokseen Karet. He wrote a tool called MyNav.
Yeah.
And that was one of my favorite plugins. That's what I was going to ask you. Is there a plugin that allows you to look at like startup runtime code and say like you go to File, Open in Windows Media Player, and it allows you to rule out all that runtime like startup code so that way you know what the file parsers are when you don't have symbols?
So there's a couple of code coverage plugins specifically for taking like dynamic traces and then applying them onto Binja's analysis. So there's Lighthouse, which is used in Hexarrays as well, for Marcus Gassel. In fact, actually, he just did a release just a few days ago, like a fresh version with a bunch of fixes and stuff in it. So you can see that that's in here. This one is actually an animated GIF, and it's kind of funny. He's joking that he's trolling us because if you like this view doesn't support animated images, but the where'd it go? The actual no, Marcus Gassel. Oh, come on, I'm spelling it wrong. Sorry, Marcus. There it goes. There we go. So if you like on a real browser, did he get rid of it? Oh, that punk. It used to switch back and forth between the Binja view. There it goes. Yeah, it's just on a really slow delay. So it supports both, which is really cool that he's actually got both of them on there. But there's also another one that's Binja only called BN-Cov. Same kind of thing. It takes like dynamic traces and annotates it onto like a static analysis. So that would be one way to do that. I'm trying to remember. So I've seen a lot of Yoxin stuff. I haven't seen that particular one because like he also did Diaphora, which is like bin diff. The other famous plugin from Zynamics. There were three apparently. There were three like different things, and then Google really only cared about one of them. They only cared about VX class, which is why that one disappeared and went away. And then BinNavi and
BinDiff's great. Yeah.
BinDiff's solid, right? That's exactly. Yeah, Binja has bin export support, right, which lets you like take database information, run it through BinDiff, and get it back out. And so you can also use BinDiff with Binja as well.
thanks to Christian Blickman for maintaining that project. It's
Yeah,
amazing.
still there. Like he stuck around from those Dynamics days, exactly. And he's like the one sole person maintaining it, as far as I know. There.
Yeah, I live in Berkeley, so I just had lunch the other day with Ralph Rolls. He lives in Berkeley as well, and he's
Nice.
he used to work at Dynamics, so it's great talking to these guys. So cool. Let's have you show us some cool stuff. I'm looking forward to it. So.
All right, so let me just start with I guess I'm going to open the DLL that you were looking at in stream, but first I'm going to just start with kind of like obvious sort of differences. I've navigated it before, by the way, so it's at that lib state. Normally I would show up at like main or the entry point, but because I've opened it up, by default Binja remembers where I was. So that's kind of foreshadowing for what's coming later, right? Entry point. Like
I've seen that global struct before.
Yeah, you might be a little familiar with that one. So the actual like the default normal view you get in will be this. Like one difference is Binja shows decompilation essentially by default. Unlike the other tools where you kind of initially are always dumped into assembly. The only reason I was showing it here is because again it just remembers what I had last up as I was exploring this file. But normally you're gonna look at this, and it's also, you'll notice you can just scroll between decompilation. So it's like its linear view is not like one function at a time. You can actually just see all the decompilation as you go, which is kind of minor, but I always forget that the other tools don't do that. Then of course you can switch to disassembly. I'm hitting I to switch between like IL views, but I can also hit tab or space to switch between graph and linear view. Very much like IDA. Like honestly, we were big IDA users, right? So a lot of our hotkeys, N, semicolon, Y, like it's the same thing. You can customize them and change them in the hotkey menu, but like by default, like I don't know, yeah, we wanted to basically be able to memorize the same things. So yeah, so like I said, space to switch there. You see our graph views. It's there. One thing that's like the entry blocks and exit blocks are kind of like this little border around them, which when you zoom like way out, it's a bad function to show it on. When you zoom way out, you can see really quickly where the entry and where the returns are in the function, which is kind of nice. Also, you can the zoom is much cleaner and faster. If I have my other mouse with like free scrolling of the wheel, you can like just flick it and zip by.
Somebody's asking about the X hotkey.
Yeah, X is there and it works, but all it does actually is focus you this menu, which is always up. So in general, you notice that we don't have as many UI elements, right, than the other tools. We generally are a little more sparse. But like we always do show cross references by default. So that's actually one big difference. What IDA has their bar up top, we have that on the side. We'd rather keep your vertical real estate, which is usually where you're scrolling. Let's get a little more precious usually. Also, I see a bunch of familiar folks on chat, so it's good to see everybody. But so this is new. Like I said, the 4.0 stuff. This is very different. You've got a little more flexibility, so you can turn on and off like your types view or your stack view, and you can move stuff around between the left and right. We actually at the beginning of Binja had a really flexible UI, much like you were talking about with X-rays, like drag every dock widget like everywhere. You can drag anything everywhere you want, and we kind of didn't like it. We actually got rid of all that and like sort of had a more forced, like, no, this is where this element goes. This is where this element goes. And, people wanted a little bit more flexibility. So now we're kind of going halfway back to what we had before. So you can't move anything absolutely anywhere, just because I feel like it's too easy to like lose things. It's too hard from like UI testing perspective. And so to get good design is kind of more annoying.
How is it with the initial auto analysis? Like I was showing the other day with IDA, you got to close a lot of the tabs, like the navigator bar and the functions view, because all that stuff in the UX slows it down drastically.
Yeah. We have actually had bugs like that before where that was the case, but generally speaking, we test for that and we actually consider it a bug whenever, like for example, the symbol list being focused changes the analysis speed versus not having it up, right? Like that's
right.
So yeah. And the other thing too is to point is we're multi-threaded. For both our analysis and our decompilation and everything that's going on. And so that the goal is to be responsive. And not only that, but like because our analysis is multi-threaded, when you're scrolling around, like say you've opened up a massive file and decompilation is still going, right? And you're seeing like all the colors fill in as things get analyzed. When you go to a function, that function gets added to the analysis queue at the top of like the priority queue. And so the next thread that's available, it just goes and grabs it. So it's meant to be a little bit more responsive and usable kind of while it's happening. Boris says hi. Boris the dog, if you know Sergey. So yeah, so like this is like, but it, to a large extent, it's very similar, right? It should feel too different. You're going to have disassembly, you're going to have decompilation. Like I said, the fact that you can look between functions at decompilation level might be a little bit different, something people aren't quite used to. It's kind of a nice feature. Also, the split view, where if you want to look at both disassembly kind of side by side, and you can select a bunch and like see all of the related instructions. That's one that's nice and not nearly as well done. So like it highlights all the associated assembly instructions, and like Giedrick does that, but not real well. It's like mapping for instructions is not the best. Like for example, we'll even show you like the function prologue, because those arguments are part of the setup for that call. Right. So the other big thing though, it's different about Binja. So I would say the three things that tend to stand out to people the most are, one, the UI, like you were saying earlier. Like we really are intentional about UI design, and we work really hard. In fact, a lot of the 4.0 stuff is really about making the UI. Even like we recently redid all of our icons to make them consistent. Like it's like the line weight of all the icons is basically the same now. It's like just they were kind of a little more random before, like little stuff like that you don't really think about, but when it's done right, it feels really clean and easy to use. Making things that like just work. Like a great example is if I've got a file open and I just like drag and drop a binary onto the window, like let's see, if I didn't already have this thing open, and then just like an empty window or whatever, I can just drag a file directly into it, right? Like I don't have to do with Ghidra. It's literally like 12 clicks to be looking at the decompilation of a file, right? And this just does it like out of the box. Like there's no pop up, there's no asking you a bunch of questions. Now, if I wanted to go back and be like, no, actually like change a bunch of settings, like I can do that. It's all there. I can control every setting possible thing you could think of. But just do the right thing by default. So that's a big sort of philosophy of ours. It's just like do the default, the normal thing, do the thing that's right for most people out of the box, instead of making people kind of like learn and guess and figure out what they should have to know or not know. So one's the UI. The second thing is our API. We have a really, really good API. It's available in both Python, C++, C, Rust, and we see a lot of plugins. We have a huge plugin ecosystem. There's a built-in Python console that's really nice, and we have things like it's actually Python, which like no other tool literally has a real Python API. You've got Jython and Ghidra, and IDaPython is itself basically a C wrapper. Like it really feels like a C wrapper. And there's been a couple of like attempts to make it feel like Python, but like for f in bv.functions printf, right? Like it's an iterator. And if I actually type it right, it says printf. Right, like it just does the thing you want. Or printf.start, if you want like the start address of every function in a binary. So like it looks and feels like a real Python API. So that's like probably one of the most obvious things, is that people, like once they start writing plugins on Binja's API, they're completely ruined for anything else. The API is really powerful. And then the other one that's really distinct is our ILs. So like low level IL, medium level IL, high level IL. Every other tool uses some sort of intermediate representation. Ghidra has their SLAY spec, which converts this native opcodes to P code, and then Ghidra has their microcode. But like neither one of those cases was it really intended to be something that the users interacted with or looked at. It was just like a behind the scenes like thing that they did. Whereas from the beginning, we've got both APIs, UIs, and it's part of the process. So like, for example, like if I want to compare the low level IL to disassembly, low level IL is like very much one-to-one instructions, like native assembly to a sort of virtual opcode set. And so like literally as I'm like down instruction at a time, it's almost like one-to-one. You can kind of see it like going at basically the same rate. Like, right, it's very, very readable pseudocode for like the native opcodes. But then when you go to like medium level IL, it gets a little bit more abstracted. And so now like there's no stack because there's just variables, right? And so you don't see like stack operations, you just see variables. Then you go to high level IL, and there's a bunch of folding and nested for loops and if statements. And so like you see like more like C code that you would expect. There is also actually pseudo C as well, which is like actually syntax like C. Like it just adds semicolons, braces, new lines, and like casts look like C style casting. So for a while we had high level IL, but we didn't have this pseudo C. And people were like, when are you going to get a decompiler? We're like, we have a decompiler. We just don't decompile to C. We decompile to high level IL. And there's even things that like high level IL does, which are much nicer. In particular, like around argument naming for like calls, it will show you both the name of the function argument that you're calling, as well as whatever parameter is being passed to it, which is not something that you can show in C. Like it's not like valid C syntax. So like it's kind of more readable. So I really encourage people to try. Even like this is like an unsigned comparison, right? Like because at disassembly, if a comparison is signed or unsigned, but you don't necessarily know in C. It's sort of implicit. So anyway, yeah, I babbled a lot. Have I missed any questions? Are there?
Oh, well, Ruben just lost his chance of winning the prize here.
Oh no.
That was good. I'm just kidding.
You better be careful. Don't get added to the ban list.
Yeah, Seth is asking, what's the difference between a community version and enterprise?
Okay, so yeah, that's a good question. There's actually a couple different versions. And so just to be clear, oh, actually, all right, so let's start with this. There's a demo version that you can download right now. This is actually going to be rebranded as free. So in 2 weeks, when we release 4.0, the stable, this is actually going to become Binary Ninja free. And you're going to be able to like save and load databases. So that's like the biggest difference. I think it's even multi-threaded. And it's explicitly not meant just to like for a temporary time, kind of eval, but it's actually like, hey, it's free version of Binja. There's no plugins. It doesn't have all the architectures, but it's intentionally kind of free. There's also cloud. We actually have a browser-based one that doesn't have a lot of the same UI stuff, but has all the architecture supported on it. And then there's the actual like paid versions where there's commercial, non-commercial, commercial, and enterprise. Excuse me. We actually used to have more things that were only, these two things used to only be in commercial and above, and we actually added them into non-commercial. So we're just about to add the projects view that I'm demoing here, where I said you can like link up binaries and have like a collection of things that are related. That's actually only going to come in the commercial version. So it's the first feature in like 8 years we've added only to commercial. And then and then headless is the other one. So the other really cool thing that we have is, like I said, our API is really it's really important to us. Actually, I don't know if I done this. If I set this up, yeah, I actually haven't set this up yet. So you can actually see what the process looks like. So if I run this install API, so you can add like you can add Python to your to your Python path. And now if I like import Binary Ninja, I can do any analysis that I wanted in the UI purely in a Python REPL or in any other like kind of like language. There's no UI, there's nothing. Like it's really good for automation and scripting. And so that's headless mode. So that's right now the one main technical feature that the non-commercial like version gets. And then commercial usage, obviously, if you're using it for a company, you're supposed to use the commercial one. And then you can also apply a student discount, which is 75% off to either one of those. Enterprise, the one I'm using, has like all these other features. It's meant for big companies like floating licenses and collaboration chat, like a couple of things like that.
How's the support for like debugging stubs for different types of OSs out there? I remember one time, it was a long time ago, working on a project where we had to write a debug stub for Symbian smartphones, and it was a nightmare.
Yeah, so you can, we do have a built-in debugger, and you can connect it to, I think it's the GDB protocol, even though we use LDB locally, for example, for a lot of our
server,
actual. Yeah, so like it's GDB, it's a gross protocol. If you've ever actually looked at how the protocol is implemented, it's super bad. But theoretically, actually, there's two ways you can do it. So one, you could do that. And remember I said like a lot of stuff, our stuff is open source. The debugger is actually a plugin that is open source, so it's C++.
Oh, nice.
But you can actually go and modify, where is it? The actual debugging backends are, yeah, and those like Python APIs for all of it too. So you can also script out the debugger, which is really nice too. You can integrate debugger scripting in Python somewhere in here. I don't remember the exact. I can ask my coworker who worked on this, but like, oh yeah, here's the target. You can see all of the things you can debug from and to, like in the docs. So you can not only modify the debugger yourself, but two, if you have something, you can also just use the API to write your own debugging backend. And then three, you can also just speak GDB protocol. Headless is not coming to non-commercial. That is commercial only. Headless is and always has been only commercial and is staying there. But you have the full API. So to be clear, like what I'm doing here in the console and running all the plugins, all that works on personal, right? So you have the full API. You just don't get the pure headless version of it where you can access it for like batch processing. And you can kind of even still do batch processing. Like you can like, like for, with Binary Ninja to like open out load f as PV. It's even like context managers and stuff. Like you get normally Python stuff where automatically closes handles and stuff. We can do that with our binary views, and now I can do for f for in BV.function. So like this would actually like iterate over every function in every binary in that, right? And the difference is I have to run it like in the UI. I can't run it separately in the console. So that's the main thing. Yeah, exactly. If you're processing 10,000 samples for personal use, right? I mean, there are people that do batch processing of files, and I'm sorry to them. They can't use headless and personal, but we try to limit the number of things we only put in commercial pretty heavily. But yeah, otherwise it's pretty similar, right? You've got symbol lists, like type views. I would say that like most of the things you expect to kind of be there are, along with some things that maybe you would not have expected. Like I said, like our AI stuff we can show off, some of the collaboration stuff that's in there. Like I said, that's enterprise. Oh yeah, like the type viewer uses Clang. Somebody asked earlier about LLVM. I was going to mention that. We do actually use Clang to do all of our type parsing. So the nice part about that is if you want to like, insert some like C header, C source information, you can actually specify any Clang parsing parameters. If there's if-defs or whatever, like you can actually like specify flags to Clang to get it all parsed out. You can also, I think there's just like an import header file directly. Do we have it in here or is it a different menu? I think that's header. Yeah, import header file. You can literally just point it at some path and pull in a whole bunch of stuff there. And this is also relatively new in the 4 release. So you can see like it used to be you just had a giant list of types like in like C format, whereas now it's like it's broken up. You can see what's in libraries, what's debug information, like the fact. So I open up your the DLL that you were using, and the fact that it applied to PDB, I get all the types of the PDB here, and I can search them and see the what its analysis is. Although it's not a whole lot of types in this PDB, they're all pretty much empty anonymous ones, or not anonymous, just empty ones. Microsoft does it a lot, their PDBs. And then you can add your own doing very, very similar stuff. So instead of like hitting the insert key, you hit I to get the same kind of thing. Let's see, stack view. Yeah, so stack views is nice. You can look at what like Binja thinks about the stack of any given function, where the variables are, and you can see like the gaps between them. Gaps are kind of interesting too. Like if you've done a lot of structural recovery and you're used to like, actually here, let's go to that. I think you had protected, was it this one? Validate access to protected page. I think that was the one that you.
Wait, to protected page, was that it?
Or protected module.
Must have been protected page.
Yeah, it is. It is because I recognize the oh yeah, this is decompilation. So go back to disassembly. Yeah, there's that MIT lib state, right? Yeah. So like for example, if I wanted to like, it's like these bytes are undefined here. There's nothing either because, well, I mean, we know obviously, right, that there's a structure here, right? Or rather, and I'm cheating off your notes from your previous stream, that there was, it's like there's a structure here and there was multiple things. But like these empty bytes, this is like interesting. I can actually just select this whole thing and just say like, hey, hit S to make a structure there. And like that whole thing has now been converted into, just struct1 like his default name. And I can edit the types. So I can change them here, but it's like you don't have to actually define particular fields, like right, like in IDA you might be used to, you have to make like a character array or something to pad out like those unknown bytes. Like no, like you can just have unknown bytes and like filled in later, figured out, like you don't know it. In fact, for example, like this offset hex 50, right, is where you had that one particular structure. So I could like select. I think that one you said was it like 32 bytes?
Yeah, they're all
2, 3, 4, or here 5, right? It was 5 D words.
5 quad words.
Or 5 quad words. All right, so 1, 2, 3, 4, 5. And so I can actually just select all those and hit S again. Actually, wait, I can do it here. I forget which. Oh, here's another one too. Like if you hit G, you can actually hit. I think I have it in my history. No, not this box. Right, you can do the same. Like I can use the symbol and go to like whatever offset I want. So if here's the, so 1, 2, 3, 4, 5. I could just in the UI select them all and like hit S, right, to create that structure right there. And so you can see like it's automatically gonna create a structure inside the other structure. I forget this was called.
First one was a base address, I believe.
So the struct itself is image information, right?
Yeah, that's what I call it. Then.
Actually, wait, this is the variable, so this will be image1. We'll call it image1, and we'll name the struct image information. And so I can just hit like 8, and it turns them all into like int64s, or I can hit 4 and turn them all into whatever. I can hit asterisk, turn them all into pointers. There's a whole bunch of or sorry, O is the pointer, asterisk to array. I think you can I think it's asterisk here. Yeah, hit asterisk turns it into an array of whatever it is. So there's a bunch of little hotkeys that make it really nice for kind of, and because I'm I'm doing this like live in the memory, like in the bytes there on the file, I don't have to just edit the type definition. Yeah. So see these things, I can do it like in the actual bytes themselves and see how they're decomposed, or like if even if I was in the debugger, I can do it with the raw like actual values of it, right? Instead of doing it there. So that's actually super nice. And of course you can undo it. It used to be a way funnier joke before Hextrace added undo, because like anything can be undone. Name types, whatever.
Yeah, so that's still seen as the number one benefit to Geeter coming out is the Control Z.
They claimed they were working on it beforehand too, because I talked to them at Recon several years ago right when Geeter was announced, and I was saying how I appreciated that they still hadn't done undo yet, and they're like, we're working on it. It won't be too bad. We promise it'll be out soon. Yeah, they did eventually implement it. So yeah, like we actually get along pretty well with the Hextrace team in general.
Oh, they're great. Yeah,
they're a good crew. So yeah, so like I'd say like just the ease at which you can, or if like I want to change like the type on this and actually make it so like a struct, like an array of those, right? You can just create an array of all those right from there. Update live, cool. Name the fields. The other key thing too is that you notice the cross references. This is actually super nice. So if I've actually got like this type, I can see cross references. Let me go here, right to let's go to the glib state, because I've created that struct now, and I just picked some random size, right? Like I don't know how many bytes I actually picked. It may not have been the right amount, but I can see cross references across all the functions, just like always. It's finding all of them, which is really nice. And this is also something where like you'll see actually if we go to like the type itself. Let me see here.
Yeah, so if it's nested in there within that big global struct, when you go and decompile it or even disassemble it, how is it identifying the offsets correctly, or is it you still need to define the parent?
No, it will. So there's two ways to do it. One, in this case, I've made just the big one. I've made the child one, and they will both show up, right? Like I don't know if there's any cross references to one of these. That's not particularly interesting. So it will actually show like struct dot whatever. If they're defined. You can also do offset pointer types, right? So like it is possible to say like, oh, this is a struct that exists at some offset of something else, but just treat it as its own struct right there. So you can, I forget actually, I don't do that enough. I have to go check. There's like literally docs on exactly that process. So I think it's under working with types. Let's see, offset. Yeah, that's one of them. There's another one, offset types. I forget. So yeah, there's actually it's another good point is that all the docs are online. Docs.binary.ninja, API.binary.ninja, and there's even, as I said, we have both the development development and stable build, so you can actually see both of those. So if I hit, I'm going to expand on my phone. 1 second. Dev-docs, which right now, no thanks, Chrome. I'll close them down myself. So like even as you're doing that, those are all there. Time travel debugging. So John, the short summary is that we have support for time travel debugging. If you go to like the user manual under the debugger and search for time travel debugging guide. So there is like a walkthrough on doing it with WinBag in particular. I don't know as much about the details in the kind of future roadmap for that. We have a public Slack. You can join the debugger channel just for questions on it. And as I said, the debugger itself is actually open source, which is kind of nice. So we've actually gotten some PRs from people sometimes. In fact, I think there's an open one now. So yeah, somebody wanted to add support for the TTD as a part of the API. So there's actually a PR waiting to be reviewed exactly for that. So it's kind of nice. Thanks, Jada. Do we have C-tree AST? Oh yeah, that's a good question, Nux. Yeah, so we do actually have a true AST form as well. So like if I'm in the high level IL, but that's another, by the way, difference is, you notice I went in high level IL decompilation, but it's still graph view. You can actually get like graph view decompilation. I know a few people who this is their default view. I still find it super weird. I want my like decompilation like this, and I want my assembly like this because I'm just old school. So I want the graph disassembly and I want linear decompilation. But you can do graph decompilation. So anyways, this like here is current function in the API. there's like an AST, or rather the high level IL form of it has an AST, or is it root node? I think it's called root. Yeah, so there's like a root. There's like an AST form of it that you can walk specifically to do like AST style stuff. Although I don't use that API much, so I don't use it a whole lot. Yeah, thanks for posting the Slack link. Yeah, Lumina's a good question too. We do have so there are other people who have written actually Binary Ninja plugins that will work with Lumina. I don't remember if it's in the plugin manager. No, I think it's like a separate one. I didn't want to like make Hextrays like super mad if like we were trying to like, so there is somebody else has written a plugin that will work with like the third-party Lumina servers that will work with Binja. So it is possible to do that. But I think what makes Lumina good is not so much the plugin is like the ecosystem and all the data that it could live in it. We've been talking about doing like an open source implementation that would be like a public repository, a public database, and have plugins for IDA and Gira and Binja and everything that could all go into one place. I think that would make it like even more valuable because everybody could benefit from it, everybody could contribute to it. But we haven't done that yet.
Yeah, it would be nice with signatures and stuff for library code, like we was talking about before. Like, you know, you get the new version of like IDA, for example, and it's got a version of libc.so, but it's just a specific version that's probably the most recent, as opposed to like the hundreds of versions of libcrypto. And it'd be amazing if there was just like a massive global one that would just.
Yeah. So the other problem with that actually, and this is something that I think is important, is that all Flirt, Flare, like all those existing like signature libraries, they work on very specific byte patterns, right? Like they're very like antivirus from the 80s, basically. It's like that's basically how they work, right?
Flare is fun.
And so and also just getting stuff built and trying to get like an actual like build that will work with it, because it's not just like, oh, just give me an SO or a DLL.
.a file,
No, you have to actually get the A and the A. So you got to build it anyway. All that aside, for a long time we want to like solve that problem with an IL based approach, right? That's the thing. Is like part of the reason we've never done that is because we're like, I don't want to make something so brittle. I don't want something that's so narrowly focused. I want something that's work on intermediate language and uses program analysis, and so it'd be more flexible. And I want to be able to recognize like, you know, the graph relationships between things. I mean, a little bit more about like how VX class works, right? Like VX class and BinDiff and BinNavi, like their approach was to apply like graph theory matching type things to binaries, and they're doing it for like binary to binary, or in the case of like VX class, like many to many, like family kind of analysis. And that's the kind of thing I think is ultimately the better solution for like library matching. Like you should be able to identify a libc because it's libc, no matter the architecture or the compiler. Like this feels like there's a generic problem. But yeah, right now it doesn't exist.
Yeah, I think it was Checkpoint or FireEye created a neat tool where you can actually take from the IDB file. You can take the signatures and symbols and such from the IDB file, and then you can apply that against something that might be statically compiled. I thought that was nice.
Oh, that's nifty. Yeah, so we have we do have a like import from BNDB. What's it called? Yeah, import debug import from BNDB. Yeah, so like this one, BNDB is a binary ninja database. We were not very creative at the beginning. We 100% matched a lot of stuff that was similar, I think, for IDA. So binary ninja database, you could pull in some of that information over. Yes, so RTTI is a really big topic to dive into. So I'm going to instead direct you to the docs, because we do actually have some really nice support for inheritance there. So here, read this. It will do a better job explaining than I could, and explains how we can do it. But you'll notice like we actually can do like, oh, there's offset pointers, by the way, too, which I was mentioning earlier. You can do like multiple inheritance, and it does it even cleaner and kind of better implemented in terms of like how it shows it in decompilation. You get cross references to both like the base as well as that class. Like it's really, really nice. So check out the docs there. In terms of RTTI in particular and pulling out debug information, we don't have any plugins that will actually automatically extract that. I mean, if it's in like Dwarf or PDB, but I think there's some particular RTTI debug parsing that we don't yet do that we need to do. But in terms of like the core's ability to like support that kind of stuff, yeah, check out like if you go to the docs user manual C++, that's the way to go from there. But good question. HNSW. Have we looked at and search? Is this a troll thing? So I'm not sure. Oh, okay, nearest neighbor. Yeah. I am not our our program analysis expert, so I'll defer to my coworkers on that. I made the joke earlier that I'm like the worst developer on the team. There's a lot of other really smart people I work with, so I'll have to ask them specifically about that. I would say that like we've only done a little bit of exploratory stuff in terms of like the matching problem, but yeah, we've thought about that one a lot. Let's see.
And just a quick note, I know we've got people watching on Twitter as well. If you are watching on Twitter and you want a chance at winning the Binary Ninja license, you need to get on YouTube or LinkedIn to be able to make a comment to compete on that one.
That's a good warning. I should give him a couple minutes to get caught up. Yeah. So I think that was the majority I wanted to show you on that particular file. Like I said, you've got kind of the same types of things that you would expect with IDA. You can hit Y, you can hit insert a type. Oh, one thing you can do too is I kind of showed it briefly, right? But that the S, I selected a range of things, just hit S. Just in general, like S is sort of like the magic structure hotkey. So you can select a range of stuff, hit S. You can see like, oh, there's an offset of the structure being accessed, hit S, and it creates a member there. It kind of like, it's like the read my mind, do the thing that I wanted to do. So yeah, like when I create that structure, I just literally select it all and hit S, and it does the right thing for you. I think I mentioned all the hotkeys there. Yeah, so I think struct type creation is actually really nice. It's been improved a lot lately. So let's see, any other questions?
Yeah, if we missed a question, we didn't ignore you, just probably just missed it. So please post it back up. But yeah, definitely want to check out, what's it, Sidekick again?
Yeah, so let's talk about Sidekick. Although I just realized I think this is the version without Sidekick enabled, so I need to restart real quick. Yeah, Sidekick is here. So like it's AI. It is a separate paid thing. So unfortunately, because it uses a bunch of machine learning models and some large models, also used a couple of OpenAI ones. Like it's a mixture of a whole bunch of things. It is a separate paid service. So I apologize if I could have made it free and built in. That would have been nice. But here's the, let's see if I pick this one up. So yeah, Sidekick is basically all the things like you would want AI to be able to do. Like if you were opening, let's like open this one, for example. So here, like I said, this is a web server, light HTTPD. This, I usually just sort functions by size because I want like a big function. So one of these here is as I go into test on. And you can see it's already like, hey, here's some things I want to do. I want to recover and define structure types. So this is super nice. Like it will actually
that's cool.
Like create structures for you, which is one of the most tedious parts. Now it's not going to be flawless, right? But in fact, it will take all of the well, okay, a couple things though. Let me just show you first. Let me just first like say, yeah, do all the things, right? So it's going to go ahead and do all that stuff, and we can actually watch it create the types here. What is unique about this is actually before the very first thing it does when it creates structures is first it's going to actually identify all of, we call them components. So it's just like, how like IDA has like folders now, right? Again, another one IDA and us 100% like we're like, oh yeah, you did a good thing there, right? So there's a lot of being inspired going on. But the difference is it's not just like you can create a folder, you can organize things, but specifically this is the machine learning model like clustering like functions. It's trying to identify things because like shared resources, these all hit the same structure. So like first it tries to identify all the related functions, and then it does the type recovery, right? So if you try to do type recovery in the whole binary, like good luck, or structure recovery in particular. But if you do it just there, it's a much more solvable problem. So you can see we've got like a whole bunch of structs that are created. Some of these will be nested structs, so structs and structs. It's like it's just made them all. Now they're all like just empty structs for the most part. And that's not true. A couple of them have actually fields. You can see that there's types here. Here's a good example where like struct 29, Sidekick has only made these two. It's got a 64-bit integer and a 16-bit one down here. But we can actually see Binja is just letting us know like, hey, by the way, I do see a word size, a keyword size, a dword size access at these offsets. And so even though Sidekick hasn't automatically made those members, we could actually just be like, yeah, create all those members. Like, and so anywhere there's an access at an offset here, like create that member for us. And so it just will pick them all and do kind of a default. So that's just a Binja thing, like unrelated to Sidekick. But sidekick like did us a favor of like creating a whole bunch of these structures already. I mean, actually see 2 of them are even arguments to this particular function. And so now we can see like, yeah, we're accessing like these fields. But the other one is, it would be nice if like we could get quick unlist the video function. Oh no. Yeah. So Robert, it's I know. I have like a long-standing like joke about like functions don't have sizes. And you'll notice this doesn't say function size here. It says function total bytes. My argument is basically functions have a start. They have like an, you always have to have a place you go into the function. That's what you call, like where the CPU goes to.
At the edges.
Yeah, but like you can have multiple returns, right? And you can have basic blocks that overlap. You can have functions interleaved with other functions. So like, what does a function size even mean? Like how would you have it? In fact, if you look at other tools, if they have a function size, it'll be different in different tools because like they have different understandings. Can a byte be in the same block twice? Can basic block be in 2 different functions? Can like all these things will result in slightly different numbers. So
getting too philosophical here. Huh?
I know. I'm sorry. It's my pet peeve. So here's the more interesting stuff though. Like a sidekick has not just made a whole bunch of names. Like it wants to actually like name a whole bunch of like structure fields for me. So like that's a whole lot of like, thank you for saving me the trouble over reverse engineering these, right? And just looking at them, like these are all like they seem reasonable. Is running current time. We can go look at the struct cross references, right? So we could try to say this is struct 2, field 3D8, right there, right? Oh, and this is something I actually haven't done. The new UI, I can now take the cross references and I can actually drag them over here. So I can split the view down this way. So yeah, that's actually kind of nice. All right. So I can see all the struct. So I actually could go through and look at these and be like, do I think that name makes sense, right? Is running a good name for it? Like walking through all these cross references. Or I can just be lazy and be like, yes, please do all the things. And select them all and be like, yes, rename everything. Right. In which case, also there's a new command B just like hides all the like the sidebar stuff if you just want to go back and look at this, which is kind of a nice hotkey. Sidekick and the NDA and some reverse engineering projects, do you use the customer data to train? Good question, Knox. The non-commercial version, we make no guarantees about non-training your data. The commercial version of the Sidekick service, we do not train or use your data. However, we do submit some of it to OpenAI. We're using APIs where they claim to not be training and using it and retaining it as well. But it's all documented in the docs. It explains all that stuff. And Abraham, when do I think Binja will replace IDA? That's a good question. It depends on the person. For some people, I think we already are. For other people, out of their cold dead hands because they're IDA for life, right? So I think that technically, for a lot of use cases, we already have advantages in some ways and disadvantages in others. I mentioned earlier our decompilation isn't quite as good. That's actually relatively. It's not even the hardest problems I think to remain. There's a couple of program analysis things that we're applying, a couple of improvements to our decompilation control flow restructuring. I think that'll be like, it's already very, very good and very, very close. And in most cases, but
do
again,
you support the architecture of something like a screaming goat? That's
I have never supported screaming goat architecture, unfortunately. Yeah. Although actually, good point though, is that we do have third-party architectures. So like you can implement your own custom architecture on Binary Ninja and get decompilation out of it actually. So yeah. So like there are like other like what's a good one? Game Boy, GameCube. These are all just like the file format parsing. I think these are not architectures. iBoot. No, another format one. Oh, this one actually, here we go. This is a good one. This actually implements both the architecture and the loader. So what is the Game Boy CPU? I forget it's not Z80, is it? Z80 was NES. Sharp LR, there we go. Anyway, somebody else implemented, Carl did, implemented a plugin that would allow you to decompile any architecture that you want to add. So it's a little bit more like Eater in that regard. Again, like you can extend it with custom architectures and get decompilation. We don't charge, like I said, with the exception of nanomips, like per architecture. Yeah, so Kimball, that's a good question. Part of the answer is that's my coworker Tim's job. So I don't know exactly how he handled it, but yeah, you'll notice that this function that I'm scanning here has a lot of tokens, more than the default window size for a lot of models. So I know there is some stuff he does behind the scenes to solve that. I don't actually know how he handles it though. It's a good question. Yeah, and Joe is somebody who's implemented custom architectures, right? But like the idea is that you just do low level lifting, right? So you're like your new architecture, all you're implementing is that low level of IL, right? You like push, pop, store, load, add, subtract, and they're like really straightforward to kind of add that lifting of that, and then all the decompilation happens like after the fact. Yeah. So yeah, okay, but if you join our Slack, I can try to get Tim to to come there and answer the question later in more detail. But I know he does. Oh, there's a bunch of other stuff. I'm trying to remember how much more time do we have, Steven? I don't want to.
I mean, we're good. Another 15 minutes, whatever.
All right, so because we do have a couple other like sidekick, so that was just like the suggestions box, right? Where it was giving me like what it thought it should do for naming things. But there's several other features. There's like a notebook like where you can ask questions. Like summarize this function. Or like you can ask, you can even ask it to write you like code, like, and it knows how to write Binary Ninja plugins. So you can actually ask it a question where it's got to go write a Binary Ninja plugin, and it generates a whole separate. There's another feature called indexers, and like, oh, there we go. So, okay, so there's some description. I don't have time to read all this, but like, that's not bad. It's like a good summary length, anyways. Binja can disassemble itself, and legally you're allowed to. Our EULA actually says explicitly you may reverse engineer Binary Ninja with Binary Ninja if you have a paid copy. So if you haven't bought a paid copy of it, legally you can't. But like, yeah, if you legally have bought Binja, you can.
Have you tested that out? How good it is at writing a Binary Ninja plugin? Like, if you have an idea, like how close does it get you?
Yeah, that's a good suggestion. So here's the thing called indexes, which is the best way to show that off. These are just like the default one just does some math. I didn't, my coworker Tim wrote this. Like it's math. Basically, it's just doing a measure of like in degree and out degree. So like the number of things this calls, number of things that calls this function, and then it makes some score. So these are like high level functions that connected to a lot of things. Makes sense that main would be the highest in terms of this measure. Like, yeah, like main probably is connected to the most other things, or is like a high level function. But you can write your own. Like you can literally write anything that you could write Python for. There's like no AI required. And by the way, to be clear, the Sidekick plugin itself is free. It's in the plugin manager. Anybody with Binary Ninja can run it. Only the AI kind of portions of it are like the paid service. But you can 100% use it offline. You can use it without a paid thing at all. And it's meant to be standalone. Like this particular feature like works without it. But like, if I go to add indexes, a lot of these do use machine learning. Like it does like natural language parsing. And so I can be like, show me all of the cryptography, show me all of the file system, show me like, what about allocators? I think there's one with, it does memory management. Yeah, show me all the memory management calls. So I can add all those. And those actually use like language classifiers that are kind of on the server to try to automatically take symbols. Now, you notice though, again, some of those do work better with symbols. Some of them work without symbols. So here's all the crypto. Let's go memory management. Yeah. So like there's a bunch of like, not just malloc and free, you might hard code, right? But here's one, buffer copy buffer. That's a great name where like, like hard coded list of all the allocators is going to have that name in it. But like, the natural language models, like, yeah, this is clearly related to some memory management, right? Like, yeah, okay, that's fair. So like that's these indexers, but you can also just add your own. So, all right, Steven, what's the thing you might want to, a question you might want to ask about? This is light HTTPD, just a random like open source web server. What's something we might want to find in this binary, like a type of thing we could ask about, like either the IL, the decompilation, the assembly, the strings, or what's something we might want to do? Oh no, are you muted? Did I lose you? Yep, I can't hear you.
Hell, my dog was barking, so I muted. I was saying, what about like parsing of the HTTP headers?
Okay. All right. So find all functions with references to these strings, post, get, or put. Maybe?
Well, I didn't mean the verbs. I mean, that's fine too. I was talking about the actual like MIME and...
Oh yeah. Like just like the header parsing in general. Yeah, exactly. That's true.
I mean, either is fine. It's
well, we'll see how it does. Okay, so now you'll notice it knows to indexers have the structure. Like it's got to be called an indexer, and it's also their generator, so you have to yield them at the end. And it kind of like we told it enough prompting to do that. So get all the strings. If it's one of them, get See, here's a good example. This one I think is wrong. I think this should be get code refs, right? Oh, actually, that might work. If it's data refs and getting no. Anyway, I don't know. Like that's close. It's certainly a lot of the APIs that are right. So this I think tends to happen where it'll get you. I've had it one-shot things. I've had it like perfectly like generate code that just ran and give me exactly what I wanted. In fact, actually, we have the demo I did on the live stream a few weeks ago. It was I recreated like basically identifying a particular pattern in a kernel vulnerability. It was some like Windows kernel bug where it was like the right half of a comparison had a subtraction offset of, I don't know, some like description. And it wrote basically the Python to like parse out the IL like operations and like the comparison of the types, and then ran it, and it found like 3 things, one of which was the known vulnerable code pattern, with the idea being that like maybe the other one is also vulnerable too. You could go look at it.
That's actually a really good question, Iram. Does using these techniques affect the reverse engineering learning process? To cheat, basically you're cheating a bit, right? If you're letting AI do a lot of the stuff for you. So I'll give you an analogy. Like think about something like return-oriented programming. You can use a tool like Mona or Wrapper or to generate the entire wrap chain for you, but they usually don't work out of the box. And if you don't understand how to debug the wrap chain and what needs to be fixed, you won't get it working. So
yeah, and I think the same is true here, right? Like again, the AI is not perfect yet. It's like I don't think this is the right API. I think it actually should be get code refs. Right. And now if the rest of it is exactly right, I can try it and go see real quick. Also we should double check if there actually are strings that's that have like maybe the strings are not in code. So is post in there? Interesting. So they're here, but it's not a single reference, right? So what I would have to say is if those appear in a string, like, I'd have to like modify my phrasing, or I could just go edit it and, oh, actually, you know what? No, that should have worked. This part actually did work because other way around. What I want to do is so it actually would make this a for loop and would say if target string, where it's one of these, is in s.value, right? That would be the other way. Like right now it's doing it is trying to do an exact match, and which makes sense because it's what I told it. So garbage in, garbage out. But yeah, like the point is like I kind of still have to understand a little bit about the API. I still have to second guess. I have to look at the suggestions for names it's giving me and like critically think like, does this make sense? It's not flawless enough, but it also feels like, I don't know if you like when decompilers first came out, like a lot of people didn't trust them because they were just wrong. Like they were buggy. And so there were still people who like long after decompilers were really, really accurate and really, really useful and saved you a bunch of time. People who refused to use them, it's stuck to disassembly, right? Like I feel like the AI models are the exact same way. Like, yeah, they're not perfect now, and there are gonna be times where they're gonna be wrong. You got to fix it, but they're only gonna get better. And like, they do already provide some value. But I am a little skeptical of people using them to totally teach themselves new things and to learn, because I think they work best when you kind of have enough of an understanding to catch them when they're wrong, right? And so I'm a little bit cautious about totally like trust everything it says. Like I feel like that's gonna get problems. But what about people are making malware? Yeah, I mean, like I've seen people demo using AI to write the malware. Like you can totally learn and try stuff. An assistant rather than replacement. Yeah, that's a good. It's Rich. It's almost like it's a sidekick. Oh, too easy. Yeah, so that's why we named it the way we did it. It's Sidekick in particular has a couple other kind of features baked into it. I'm trying to think of other kind of Binja stuff I didn't show off. There's a tags UI. There's like bookmarks for like locations, custom hotkeys, custom settings. Do we want to maybe do the drawing now? Is now?
Yeah, definitely.
Let's do that. So, all right, ready? You might want to code this up. You could probably solve this answer. Yeah, so documentation, it'll actually write you the docs of functions like man page style stuff. So here's my question. How many plugins exist in the Binary Ninja plugin manager? And it must include both the community and the official repo. That's the question. First person in the chat that we see with the correct number wins a free Binja license. If you already have a Binja license, I'll extend your license 2 years. Good answer, Chaotic, but not the correct one. including the official, not commercial, but including like the official. No, if you guess, you only get, we're gonna take we'll add delays to people who guess wrong.
Yeah, you can't just write 1, 2, 3, 4, 5, 6, 7.
Yeah, exactly. You start spamming, and we're gonna like, ooh, Marcus is pretty close. Gasolin said 128. That's not correct, but it is close. Yeah, so including the official plugins. The first person that actually, so I'll give you a hit now too. The first person actually scripts this up is probably gonna get the right answer. So right here and right here are the 2 repos, and there's these JSON files that list you all the plugins. So go in there and either do a math or pull it out.
Ask AI, ask ChatGPT.
I think we have an off by 1 for one of these, but I'm not going to say which. It's really close. We're really close. I
wonder if ChatGPT would get it. How many plugins?
I bet it would write you the command line that you could feed this into. So I'll show people my answer afterwards too. I think watching them come in. They're honing in. People are getting close. I'm not giving any more hints about who's close and who's not, though, because I don't want you all brute forcing. I want somebody to actually. So like I said, if you literally look for community plugins, the listing, you can actually use listing or plugins, either one. You could use JQ. You could use a command line and grep it. I'll show you mine.
The answer must be in hexadecimal.
Oh no. There's a lot of close ones. I haven't seen it yet. And if I miss it, people can come back and tell me. I'll give you a hint. It's more than IDA's. IDA has their plugin manager open. Every now and then I check. Yeah, JQ for the win, Galen. All right. I have officially now seen a guess that's 1 too low and one that's 1 too high. So that might be enough for somebody to like get it from there. But I'm telling you, I think the first person who actually kind of coded this up is going to get it right, I bet. And I'll show everyone my command line. We'll verify my implementation afterwards and make sure I'm not doing something wrong.
This is fun. That's a good question.
I wanted something that was like not immediately trivial, but also was not going to take forever. You do not need to. That's a good question, Radu. You do not need to provide a passport to either install a plugin or to purchase the software. Y'all have figured out, like, you're generally in the neighborhood. I'm surprised that some of this scattershot is not has not landed on it, but I'm glad we got the log in the chat too, so I can.
And my questions are usually stuff like, "What's the opcode for or EAX?" It's like it takes 2 seconds.
Nice.
The answer is 0D, by the way.
See, I would have just gone to Binja, and I would have been. Or EX with itself, you mean, or
with the next double word after it?
I'm not sure I understand. Let me make sure. How did you miss any? Which one? So or EAX.
The second operand will just be the whatever double word is.
Just some value. You mean?
Yeah.
I got you. No. It turns out AR64 doesn't have that syntax, does it? I'm checking answers. I'll scroll back and make sure I didn't miss it. So don't worry, I'm not going to get too distracted. x86 32-bit. So that's what I would have done. Yeah.
Yeah, 0D.
Yeah. And actually, that's one other thing too. Like Binja is actually a really competent hex editor with like its types and templating. You don't have to create. You can also just like disassemble at whatever offset. For, like,
did somebody get it?
I still don't see it. The community does. I will give you a hint. Community does have 130. So how many are official? And you can in the UI they even show up different. So somebody has correctly done half of the problem. And I see a lot of people really close. But after I confirm it, Stephen, you can go back to me. We'll double check. Joe Rosner got it. Joe just got it. 141. That's it. There's 11 official, and I'll show you. Here's how I solved it. 100 to 200. I'm not actually going to make you do it in hex. So it looks like Rosner is the winner. if you confirm. I think that was the first, like I said, there was a 142 and there was a 140 that I saw earlier.
What was the number again?
141. So it was right. Am I doing math right? 130 plus 11, 141.
141. John Johnson said it way back.
Oh no, did he? Did I miss it? Oh, sorry, Joe.
At 12:05.
Oh, I apologize for missing it. I kept y'all guessing for too long. This is why we double check. You're right. No, John Johnson, indeed. I agree. So,
yep.
All right, now we just have to figure out how to get a hold of like John Johnson via YouTube.
Yeah, John Johnson. I mean, we can just DM on.
I apologize if you can hear the banging in the wall. Somebody's
Twitter. Are you still there, John Johnson?
Hopefully so. Got angry because he didn't get selected immediately and rage quit. Yeah, thank you, John Johnson. You guys are right. I apologize for missing that. That's my fault.
Oh, Twitter comments are coming through now. They have the X logo on them. I didn't know that.
Oh, interesting.
So John Johnson's here. Yeah, there he is.
Oh yeah, sorry. Julian came in via Twitter. I see that. Yeah.
Cool. So how do you want him to get you the information? Twitter or your Discord or Slack?
Twitter's fine. Yeah, if you want to use X. So if you said John Johnson does have an X account, or
yeah.
YouTube. Okay. Yeah. If you've got an X account, just send me a message on Twitter, and I will. Yeah.
I have a feeling some people are going to create some John Johnson Twitter accounts real quick.
Real fast.
John Johnson 99.
Yeah, I'll wait a tick before we make sure it's the right one.
Yeah, One Love Africa. You definitely you were in the range.
Yeah, there was also somebody had 140 and 142 earlier too. I saw there were some close ones. Peter, by the way, Peter's one of my co-founders of X35. He did the right answer, which is the Binja answer for it. Except it only shows. I think that's because I'm on a. Why is it not showing out there? There's two plugins there, I think. So that actually gives you a different answer because that's the ones that. What is the difference there? Oh no! Now is there going to be a controversy in the assignments here?
141. Yeah, watch out for that account.
Yeah. No, that sounds legit. Clearly, that was his handle beforehand. What software are we? This is Binary Ninja. If you mean this software. If you just showed up, Hector, welcome to the whole stream.
Yeah, Binary Ninja. It'll be on YouTube afterward. This will live on, and you can watch it.
Yeah. Check out the VOD. All right, cool. Any other Binja questions?
Yeah, last we're gonna wrap it up here. So give another couple minutes for any remaining questions. Otherwise, we will see you next week. By the way, while we're waiting for some questions, if you have any, next week is going to be with my guest. I think it's the one on Jeff. Let me double check that real quick. Also, I'm not sure. I'm not 100%, so I almost don't want to say this, but Joaquin Corrette, if that's how you pronounce his name, a brilliant developer of Diaphora and many other tools. I might have 2 sessions next Friday where he would be on early, and then the second session will be with Hugsy on Jeff Unleashed. So that's going to be Jeff is the a really amazing plugin for GDB, extension for GDB that helps with exploitation. It's lovely, and I'm sure we're going to learn a ton of stuff about that I've never seen before.
Yeah, if you're not using that, you're doing command line GDB. You're in for a treat. It's
there's other ones like PETA and stuff out there, but Jeff is just phenomenal. I mean, a good friend of mine, Wasker Tejeda, wrote an additional feature, which is basically called Heap Me, where you can do time travel debugging on all calls to free, malloc, calloc, realloc, all that. And it's lovely.
Nice.
Cool. If I could learn.
Okay. Hey, Javar, if you're a student, by the way, we do have a student discount, to be clear, that makes it only $75. So if you are a student, make sure you apply to the student discount thing. We try to make it as approachable as possible for people that can't afford the full thing. And there's also, like I said, there's a cloud version which has a lot of features as well. You can just go to cloud.binary.ninja for an in-browser free version.
Somebody said any discount code, but
No,
yes.
no discount code. Sorry.
Peter posted a little line.
That snippet's gotten out. See, but now that one says 140. I don't know. We may have to go back and confirm this. We'll double check our answers. Yeah, you're welcome,
Cool.
Scott.
All right. Well, I don't see any additional questions coming in. So thanks a lot for joining us. Special thanks to Jordan and giving away a license. I mean, one thing I got to say is the UI UX is amazing. It really looks nice.
Thank you. Really
clean. You can tell there's a lot of time put into that. So lovely. Cool. All right. Well, we will see you next week. Have a great weekend. Thanks. Bye-bye.